Welcome to the A320 landing gear and brakes lesson. This lesson covers the components, indications, and basic operation of the landing gear and braking systems. You will also learn how to control and monitor the landing gear and brake system using flight deck controls and the SD. The landing gear and braking systems are designed to provide gear extension and retraction in flight and efficient maneuvering of the aircraft on the ground. The major components of the system are the landing gear, nose wheel steering, and braking. The landing gear is controlled by two landing gear control interface units, or LGCIUs. The LGCIUs also determine the aircraft's air or ground status and supply landing gear information to the ECAM display. Nose wheel steering and braking is controlled by a brake steering control unit, or BSCU. The BSCU interprets the commands and hydraulically positions the nose wheel. Controls for the landing gear, nose wheel steering, and brake system are located throughout the flight deck. The landing gear is comprised of a single nose gear and two twin-tandem two-wheel main gear assemblies. The nose gear is electrically controlled and hydraulically operated by the green hydraulic system. Nose gear doors are fitted to either side of the nose gear well and consist of a forward pair and an aft pair. A single door is also fitted to the rear of the nose gear. The aft pair and the single small door move with the gear and remain open after gear extension. The two forward doors open and then close during both gear extension and retraction. The nose gear is totally enclosed after gear retraction. The main gear and doors are electrically controlled and hydraulically operated by the green hydraulic system. The main landing gear retracts inboard. The outer gear doors are attached to the main struts and move with the gear. The inner gear doors are hinged at the fuselage and open for extension or retraction, and close at the completion of the sequence. The nose and main landing gear and doors are equipped with proximity detectors. Proximity detectors monitor landing gear uplock, downlock, and shock absorber positions as well as gear door positions, and send information to the LGCIUs. The LGCIUs send landing gear position information to the ECAM display. LGCIU 1 also sends information to the landing gear indicating panel. LGCIUs also monitor the landing gear lever position and electrically sequence gear extension or retraction. One LGCIU operates as the primary or controlling computer, while the other LGCIU operates as a backup and an additional source of gear information. The two LGCIUs alternate from primary to backup each time the landing gear is retracted. If the controlling LGCIU fails, the backup LGCIU automatically takes over. Other aircraft systems also rely on the data from the proximity detectors via the LGCIUs. Some of these systems specifically rely on shock absorber status, while other systems rely on uplock or downlock status. The landing gear selector lever provides electrical input to the controlling LGCIU. The primary LGCIU processes the signal and communicates to the hydraulic selector valves to either retract or extend the gear. If a main gear or the nose gear shock absorber is sensed compressed by the proximity sensors, an interlock is activated. The interlock inhibits the landing gear selector lever from being moved to the up position, which prevents accidental gear retraction on the ground. The crew cannot override the interlock. Hydraulic power for landing gear extension and retraction is provided by the green hydraulic system. A safety valve prevents landing gear movement when the airspeed is greater than 260 knots. The landing gear indicating panel is used to monitor gear position. The three indicators represent the left main gear, nose gear, and right main gear. When the gear is up, this panel is in a lights-out condition. Select the landing gear down. The unlock lights appear when the gear position differs from the position selected by the landing gear selector lever. This is normal during extension and retraction. Down triangles indicate the gear is down and locked. Only LGCIU1 provides information to the landing gear indicating panel. Therefore, if LGCIU1 fails, the lights will not illuminate. In this situation, use the wheel page for gear position information. The wheel page appears automatically for the following conditions: on the ground, after the engine start sequence is complete, and in flight, when the landing gear selector lever is moved to the down position. When the gear is down and locked, the down triangles appear in green, and the gear door indications appear closed. Select the landing gear up. When the landing gear is in transit, the gear door indications turn amber, and the triangles are displayed in red. Once the landing gear is retracted, the doors are displayed green, and the landing gear triangles extinguish. If one of the proximity detectors is faulty, it is possible for one of the triangles on the wheel page to display red. The red triangle indicates that the LGCIU senses the gear is not down and locked. The limitations for normal gear operation are: do not extend the gear at speeds above 250 knots. Do not extend the gear above flight level 250. Once the gear is extended, do not exceed 280 knots or 0.67 Mach. Do not retract the gear above 220 knots. Another indication of gear position can be found on the engine warning display landing memo. When the aircraft is below 2,000 feet AGL and in the approach phase, the landing memo appears on the EWD. The landing memo includes a list of items to be accomplished before landing, including extending the landing gear. Before extension, the gear step will be blue, as an action item needing to be accomplished. After the gear is down and locked, the landing memo will turn green. In addition to the ground proximity warning system, too low gear warning, fault messages on the EWD alert the crew to gear status and malfunctions. Landing gear, gear not downlocked, indicates that the aircraft has sensed a malfunction preventing the gear from locking down. Landing gear, gear not down, appears on the EWD if the gear is not down and locked, either due to malfunction or crew error, and the aircraft descends below 750 feet radio altitude. In this case, the red arrow to the right of the gear handle will also illuminate. In both cases listed above, the landing gear indication on the landing memo will not turn green, but will remain a blue action item. In the event that normal landing gear extension is not available, the aircraft has the capability to use gravity to extend the gear. The gravity gear extension hand crank is located on the aft portion of the center pedestal and is safety wired to the pedestal. To use the hand crank, the crew must pull up on the crank, which breaks the safety wire and locks it in place parallel to the pedestal. Turning the hand crank clockwise 3 times completes the following. The first turn closes a hydraulic cutoff valve, which removes pressure from the system. The second turn releases the gear door uplocks and allows the doors to fall open. The third and final turn releases the gear uplocks and the landing gear extends into place. After extending the gear, the crew is directed to place the landing gear lever down. Placing the gear lever down extinguishes the red unlock lights on the landing gear indicator panel to provide a correct down and locked indication. After the gear has been gravity extended, the gear doors remain open, since there is no hydraulic pressure to retract them. Nose wheel steering will not be available either. Nose wheel steering is electrically controlled through the dual-channel brake and steering control unit, or BSCU. If one channel fails, the other channel automatically takes over. The BSCU processes commands taken from two steering hand wheels, rudder pedals, and the autopilot to track the localizer during an auto landing. The BSCU controls the nose wheel steering cylinder, which is powered by the green hydraulic system. The hand wheels provide directional control at relatively low speeds and are connected electrically to the nose gear through the BSCU. The hand wheels can command a nose wheel turn angle equal to angles printed on the base of the hand wheels, up to 75 degrees. The amount of steering available varies based on ground speed. Full authority is plus or minus 75 degrees and is available up to 20 knots ground speed. The amount of steering authority decreases at a constant rate to 0 degrees at 80 knots. The two hand wheels move independently. If an input is made on both hand wheels simultaneously, the combined input is summed and sent as a command to the BSCU. The summed steering input can never exceed the highest angle currently available depending on ground speed. The captain and first officer's rudder pedals provide limited nose wheel steering. The amount of steering available varies based on ground speed. Full authority, plus or minus 6 degrees of turn, is available up to 40 knots ground speed. The amount of steering authority decreases at a constant rate to 0 degrees at 130 knots. A pedal disconnect button in the center of both hand wheels allows the rudder pedals to be disconnected from nose wheel steering. This allows for you to check the rudder travel without turning the nose wheel during taxi. During an auto-land rollout, the autopilot commands nose wheel movement to track the runway's localizer signal. Steering is commanded until the autopilot is disconnected. In addition to the autopilot disconnect push button, significant hand wheel or rudder pedal inputs can disconnect the autopilot. A towing control lever is mounted on the nose wheel steering electric box. It is used by ground personnel when greater turn angles are required during pushback or if the aircraft is being towed. When the lever is placed in the tow position, nose wheel steering is inhibited. An ECAM memo message, nose wheel steering disconnect, appears in green to alert you that nose wheel steering is disconnected. This memo turns amber when at least one engine is running. When the lever is returned to the normal position, nose wheel steering is restored and the ECAM memo is removed. Nose wheel steering is available when all the following conditions are met. The aircraft is on the ground. The anti-skid and nose wheel steering switch is in the on position. At least one engine is running. The green hydraulic system is pressurized. The towing control lever is in the normal position. Aircraft ground speed is less than 130 knots for the rudder pedal actuation. And aircraft ground speed is less than 80 knots for hand wheel actuation. Nose wheel steering is operated by pressure from the green system return line for the nose gear doors. If the nose gear doors remain open for landing, as they will if the gear is gravity extended, nose wheel steering is not available. An internal centering cam within the nose gear strut returns the nose gear to a centered position after takeoff. Centering can only take place after the nose gear strut has extended. The main wheels are equipped with carbon multi-disc brakes which can be actuated by either of two independent systems. The normal system uses green hydraulic pressure. The alternate system uses the yellow hydraulic system, backed up by a hydraulic brake accumulator. An anti-skid and auto-brake system is also provided. The main gear wheels are fitted with fusible plugs which protect against tire burst in the event of overheat. Each brake also has 2 wear pin indicators. The wheel page displays the status of the braking system. Individual wheel brake temperatures are also displayed. Braking commands for normal brakes come from pressing on the upper portion of the rudder pedals or from the Autobrake system. These commands are then sent electronically to the BSCU. The BSCU then signals the application of hydraulic pressure to the individual brakes. The normal braking system is automatically selected when green hydraulic system pressure is available, the anti-skid and nose wheel steering switch is selected on, and the parking brake is off. The wheel page does not show any indication of the normal brake system. The anti-skid system provides maximum braking efficiency by maintaining wheel braking to the limit of an impending skid. Anti-skid is operable when the anti-skid nose wheel steering switch is selected on and the BSCU is functional. The BSCU receives input from wheel tachometers to know the rotational speed of each wheel. It also receives input from the Air Data Inertial Reference System to compute the forward speed of the aircraft. By comparing these two inputs, the BSCU can detect when a wheel skid is about to occur. When it senses this impending skid, the BSCU sends a release signal to the normal and alternate brake servo valves for that wheel. Anti-skid is always available with normal braking. Anti-skid is available with alternate braking unless the cause of alternate braking is a failure of both BSCU channels. Additionally, when alternate braking is in use, if low yellow hydraulic system pressure is detected, the BSCU will deactivate anti-skid. The wheel page provides anti-skid indications. Horizontal green bars represent the anti-skid system of each respective wheel brake. The bars appear in flight when the gear is lowered to indicate that the wheel brakes are released and will remain released until touchdown. The bars also indicate that the anti-skid function is armed. During the landing roll, the bars are removed when braking occurs. The bars reappear when the associated anti-skid is functioning and a release order is sent to the respective brake. Alternate braking is powered by the yellow hydraulic system. When green hydraulic system pressure is lost, alternate braking with anti-skid capability is automatically selected. No pilot action is required for this automatic transfer as long as the following conditions are met. Yellow system pressure is available, the anti-skid and nose wheel steering switch is in the on position, and at least one channel of the BSCU is operational. When the brake pedals are pressed, they operate auxiliary low-pressure hydraulic lines, which activate valves that allow yellow system pressure to apply the brakes. Although these low-pressure lines are operated every time you press on the brake pedals, loss of the green system causes movement of an automatic selector valve, which enables yellow system pressure to be applied. Anti-skid continues to function normally. The wheel page indicates that alternate braking is in operation and that auto brakes are inoperative. Yellow hydraulic system pressure delivered to the left and right brakes is depicted on the accumulator pressure brakes gauge. All the information presented on this gauge relates to braking with the yellow hydraulic system. If both channels of the BSCU fail or the anti-skid and nose wheel steering switch is off, alternate braking without anti-skid is automatically selected. Just as in alternate braking with anti-skid, pressing on the brake pedals operates alternate braking. The pedals operate the auxiliary low-pressure hydraulic lines, which in turn activate the valves that allow yellow system pressure to apply the brakes. The wheel page indicates that alternate braking is in operation and that anti-skid and auto brakes are inoperative. When the anti-skid system is lost, it is important to limit brake application, as too much pressure may result in tire failure. The green arcs indicate the maximum alternate brake pressure that can be safely applied when anti-skid is inoperative. If both the green and yellow hydraulic systems fail, braking is still possible through a dedicated accumulator. Pressing on the brake pedals operates alternate braking using pressure from the accumulator. The pedals again operate the auxiliary low-pressure hydraulic lines, which activate the valves that allow yellow system accumulator pressure to apply the brakes. The yellow system brake accumulator is only capable of providing a maximum of 7 full brake applications before the accumulator is depressurized. To prevent the accumulators from being depleted, the BSCU is deactivated and anti-skid is unavailable. The wheel page indicates that alternate braking is in operation and that anti-skid and auto brakes are inoperative. Again, the green arcs indicate the maximum alternate brake pressure that can be safely applied when anti-skid is inoperative. The small green band indicates the normal pressure of 3,000 psi that should be maintained in the accumulator. The parking brake is activated by lifting the handle and rotating it clockwise to on. Pressing the brake pedals is not required to engage the parking brake. Pressure can be supplied from either a normally pressurized yellow system or from the dedicated yellow system brake accumulator. Selecting the parking brake handle to on deactivates normal and alternate braking modes. BSCU operation is not required for the parking brake to function. Accumulator pressure is read on the top of the accumulator pressure indicator. A fully charged accumulator will maintain parking brake pressure for several hours. When the parking brake is set, brake pressure is displayed on the brakes indicator. While parked without the engines running, the yellow system brake accumulator can be repressurized using the yellow electric pump push button on the overhead panel. Select the yellow electric pump to on. A park brake message is displayed on the ECAM memo section when the parking brake is on. Temperature sensors are installed in each main wheel brake. These sensors send the temperature of each brake to the BSCU. In turn, the BSCU provides this information to the ECAM wheel page. Brake temperatures appear digitally in degrees Celsius. Green values are in the normal range. A green arc appears over the hottest wheel whenever the brake temperature is between 100 degrees Celsius and 300 degrees Celsius. The indications change to amber when temperatures exceed 300 degrees Celsius. Brake fans are installed on each main wheel to assist in cooling the brakes. When the brake's hot message is displayed, the hot light illuminates on the brake fan push button. The Autobrake system controls automatic braking during landing or an aborted takeoff. The system reduces crew workload, improves passenger comfort, and reduces braking distance. In order for auto brakes to activate, normal brakes must be operational, the anti-skid and nose wheel steering switch must be selected to on, at least one air data inertial reference unit must be functioning to provide speed and deceleration rates to the BSCU, and a ground spoiler deployment signal must be sensed by the BSCU. The Autobrake system is controlled by the Autobrake panel. The system is armed by selecting the low, medium, or max push button on the Autobrake panel. The blue on light indicates the deceleration rate selected is armed, not operating. On the wheel page, the Autobrake label and the selected deceleration rate displays. During takeoff, Autobrakes can be armed using the max push button. Autobrake's max is used only for takeoff. Select the max push button on the Autobrake panel. Let's look at an example of what happens during a rejected takeoff. Above 72 knots, provided the ground spoilers are armed, moving the thrust levers to idle signals the flight control system to deploy the ground spoilers. When armed, maximum auto braking is immediately applied when the spoiler deployment signal is triggered. The deceleration light on the max push button indicates that the aircraft's deceleration rate is approaching the selected rate. The auto brakes can be disarmed or disengaged by applying pressure to either brake, pressing the max auto brake push button, or retracting the ground spoilers. The auto brake label on the wheel page flashes for 10 seconds after auto brake disengagement. During landing, the auto brake system can be used to apply braking automatically. The system can be operated in either the low or medium mode. When medium is chosen, braking is progressively applied 2 seconds after the spoiler deployment signal is triggered. When low is used, braking is progressively applied 4 seconds after the spoiler deployment signal is triggered. The final braking level attained with auto brakes medium is slightly higher than that employed for auto brakes low. When the flight control computers have determined that the aircraft has landed and the wheel speed is greater than 72 knots, the spoiler deployment signal is sent. Auto braking is then initiated. The decel light on the low push button indicates that the aircraft's deceleration rate is approaching the selected rate. Accomplish the transition to manual braking by simply applying pressure to the brake pedals, which then causes the auto brake system to disarm. With the auto brakes now disarmed, the blue on light extinguishes on the associated auto brake push button. For normal runway conditions, manual braking can be initiated any time after touchdown. That is incorrect. That is correct. That is incorrect. 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 That is correct. That is incorrect. That is incorrect. That is incorrect.